Well, kids, here we are, Digital Learning Day 6, Thursday, March 26th. This will be the last video for the week. Friday, you don't have any new material, there won't be any lessons. You'll have kind of a 3-day weekend to get yourself centered again. So, this is it for the week. We are going to touch on a new topic today, still in the realm of the atmosphere. But as you can see, I'm going to be working off of section 3, air movement. And also I'll be looking at this part of the note packet, section 3, air movement as well. So I'll be referring to both of those things. I'll be working my way back and forth, and we'll go from there. So here we go. As you can see on the whiteboard of learning up here, what we're going to talk about when we talk about air movement is wind. Who knew? The movement of air, we feel it along the surface of the earth. We call it wind. But the movement of air happens at all heights within the atmosphere. In fact, the strongest winds, other than maybe a tornado, are going to be found up in the jet stream, which is up in the stratosphere. And we'll touch on that later. So the first thing to understand about the formation of wind is that air moves, as it says in your notes, from areas of high pressure to areas of low pressure. When you did your layers of the atmosphere assignment, you noted that the highest pressure was down towards the Earth's surface and the lowest pressure was up towards space. But that's not really what we're talking about when we talk about surface wind. There are different parts of Earth that heat differently. And the warmer it is, the warmer the air is, and we all know from the radiation conduction and convection section, we all know that warm air rises. And so areas, let's say near the equator, where they get a lot of solar energy, it's very warm there, the air is warm there, that air is typically rising. It's moving up. So if you were standing on the surface of the earth near the equator somewhere, should you be feeling all that much wind? The answer is no, because the air is typically going up. All right. Now, other places where it's cooler, you have colder sinking air. Hot air rises, cold air sinks. Cooler sinking air comes down from the atmosphere, hits the surface of the earth, and spreads out in all directions. That's high pressure. Because if there was a scale at the surface, the air pushing down or moving down towards the surface, it would push on that scale and raise the number, right? So that's higher pressure. So air moves from high pressure out to lower pressure. Now, when we look in the book, we can see on this picture an explanation about why there's uneven heating of the Earth's surface. And you can see that at the equator, there's more direct sunlight. And so the same amount of solar energy hitting the equator covers a smaller area than the same amount of the sun's energy hitting the curve of the Earth and being spread out over a larger area. That's why it's colder at the poles than it is at the equator. Much more direct sunlight at the equator. All right. So we've got these warmer areas here by the equator that create lower pressure. We get rising air. Here we've got cooler air where it sinks, creates higher pressure, and wind moves from high pressure to low pressure. All right. Now, that's on a big scale. This also happens in much, much, much smaller scales. For instance, let's see, wintertime, you're over in Sheboygan, maybe for a basketball tournament or a dance recital, and you drive along Lake Michigan. It's 0 degrees outside, and you can see the water. The water's not frozen on Lake Michigan. What does that tell you about those two surfaces? Well, the water must be higher than 32 degrees because it's not frozen yet. The land is colder than 32 degrees. So the difference between those two, the land in this case is colder. So the air above the land is going to be colder, which makes it sink, hits the surface, and creates wind. whereas the air above the water is relatively warmer, so the air there rises. So the wind will actually blow from the shore out into the water. All right. I know it's a lot, and it's going to make a lot more sense, especially when we move into the weather section. All right. But that's the gist of it. Now, when we look here at the notes, the next thing on the list is something maybe even slightly more complicated, and it's called the Coriolis effect. I'll read the definition first, and then I'll explain how it works. The Coriolis effect, as it says, rotation of the Earth causes moving air and water to shift to the right, north of the equator, and to the left, south of the equator. Here's what it means in real terms. Now I'm going to pull up the picture of the globe here. Here's what I want you to think of. I want you to imagine that you and I are sitting on opposite sides of a merry-go-round. Someone else is pushing us in a circle on the merry-go-round. We're sitting directly across from one another. The merry-go-round gets going, and we're spinning, and we're spinning, and we're spinning, and I take this ball, and I toss it directly to you. Are you going to catch it? Of course you're not going to catch it. You're moving. So by the time the ball gets to where you were when I threw it, you were no longer there, right? Obvious. But here's the part that you have to think about. Does the ball curve? The answer is no. The ball doesn't curve. I throw it straight at you. All right. And the ball continues to travel straight. Now, from your perspective, sitting on that side of the merry-go-round, what does it look like the ball is doing? Well, it starts off as soon as I throw it, but you're spinning, right? So it's going to look like that ball has curved. Even though it's going straight, you're moving, watching the ball makes it look like the ball curves. The same thing happens with the Coriolis effect in air and water on the Earth. The Earth is moving, the Earth is rotating, it's spinning, right? So when the air hits the surface, the earth underneath the air is moving. And so what it appears to do is curve the air or curve the wind, which has created these patterns in wind at certain latitudes, depending upon how close to the equator you are, either to the left or to the right. And you can see it talks about it curving to the right in the northern hemisphere and left in the southern hemisphere. This has given us entire global wind patterns. And if we look at this picture, it explains a lot. Ms. Galligan would be proud of you if you know about the explorers. I think you know it's U.S. history. Maybe that was 6th or 7th grade when you talked about the explorers. But when they left Europe and Columbus discovered America, he was traveling in this direction on his sailing ships. Those were the prevailing winds. They took him in this direction. All right. Can't sail the other way very easily, right? You got to go higher in the latitudes up here in order to get back to Europe. Okay. There's also one weird place down here by the equator called the doldrums. And that's where we've got a lot of warm temperatures, a lot of rising air, a lot of low pressure, right? And so you get that rising air. Is that going to blow these sails very easily? Not really. And so the explorers had to be very careful to stay in the trade winds and out of the doldrums, because if you get in the doldrums, first of all, it's going to usually rain in the afternoon, which isn't very fun. But secondly, it doesn't give you very much wind to travel with. All right. So that's a lot. That's a lot of explaining, and we only covered 2 pages, right? Air movement, air moving from areas of high pressure to areas of low pressure, and the Coriolis effect, which explains why we have these prevailing wind directions depending upon our latitude. With that said, there is no new homework for today. There is no quiz for today. Your job between now and Monday is to get everything done that I have given you up to this point. There was no homework yesterday, no homework today. All right. I will send out email reminders. If you've already done this stuff, don't freak out. You can send me like, hey, I already turned that in. That's totally fine. But I just go through the list on Google Classroom. Whoever hasn't turned it in yet, it shoots you an email that says, hey, can you get this thing done for me? All right. So look for those emails. If you need my help, you know where to find me. bswitz at nfdlschools.org, Google Hangouts, Google Meet. Haven't really done much of that with the students yet, but lots of times with adults in meetings. So if it works better for you to see me and hear me and for me to see you, we can do that as well. So when you need my help, get a hold of me. That's what I'm here for. All right. So with that said, I want you to have a great rest of your day. I want you to get caught up between today and over the weekend, and we'll start Monday fresh, continuing on with air movement. All right. You all have a wonderful day, and I look forward to talking to you soon.